Great. So we're going to talk about linear inequalities. Graphing a line, we're just going to decide whether or not where our solution is. So anytime you graph an inequality, not on a number line, but on a coordinate axis, so an x and y axis, you're going to have shading, because that means you've got multiple answers. And you're going to have to determine whether that line, or whatever you're graphing, is solid or dotted. Okay? So linear inequality in two variables is a result of replacing the equal sign with one of these inequalities. And you want to understand or remember that you must be doing some shading. And you're going to decide if you have a dotted or a solid line. Those are the two things that you need to remember. So just like if you did a number line and we did some shading, we had multiple answers that worked, correct? So if it was strictly greater than and less than, these values or these endpoints were our starting values, but they were not included, yes? So likewise, when we're graphing a line, if our line is dotted, that means it is our beginning or our boundary, but the values on the line will not be part of the solution. But if we solid in, because of the equality statement that we would see, we know that 3 and 6 would be part of our solution, yes? So likewise, when we're graphing the line and our line is solid, because we see an equal sign in that inequality, then we know the values on the line are also part of the solution. Y'all with me? All right, so let's say that we talk about ordered pairs. A solution of an inequality in two variables is an ordered pair, so whatever that point is going to be, that provides a true statement given the x and the y are substituted in. Okay? So let's see what I mean. So let's say I give you this equation. How do we know that this is a line? What do you know, Rose? It isn't? Is it in standard form? Kind of. Right, the a has to be positive, but it is an equation of a line. And the reason we know that it's an equation of a line is that the exponents on both of these are to the first power. This is really important as you go through math. You're not always going to be graphing lines. There's tons of things that we can graph. And you need to keep it clear in your mind what it is that you're seeing so that you graph it correctly and you don't get them all mixed up. Okay, so this is a line. And notice that the value or the inequality is less than. So does that mean when I substitute in 3 and 5, I have to get, is it okay if I get the value of 8? No, I have to have any value that's less than 8, correct? So when we substitute in, we go using our parentheses, we put minus with the 3 only in parentheses, and then we say plus 2, and then the 5 in parentheses, and we need to see if this is a true statement. So this says negative 3 plus 10, which is 7. Is 7 less than 8? It's true. Therefore, this is a solution. Okay? All right, let's try negative 4, 3. We're plugging it into the same equation. So negative parentheses negative 4 plus 2 parentheses 3, is that less than 8? So if I were to make a mistake, what would my mistake be right here? Yeah, dropping the second negative. We have a minus in our problem, and our value that we're substituting is negative. So 2 negatives make a positive. Is 10 less than 8? So this is no, not a solution, because it's not less than. It's kind of a substitution. Okay, so now we're going to approach those lines. Steps for graphing. Obviously get the y by itself. You want to have it in the form of y equals mx plus b. Let's remember. What is the b? Y-intercept. What does the y-intercept mean? Where x equals 0, where the graph crosses the y-axis. Okay. Apply the, oh, and what is m? It's your slope. And slope is, in words, rise. So my change in my y over my run, my change in my x. So rise over run. Just all of this is just a reminder of things that you already know, but it's nice to hear them again. Apply the y-intercept and slope to the coordinate graph. All right, less than or greater than means our line is not part of our solution. It's just a boundary, so it's dashed. If you see the equal sign in there, it's solid. Shade above or shade below. And I'm going to show you a trick that I want you to look at when we're graphing. All right, so here we go. Y is greater than or equal to 6x minus 3. What is my y-intercept? Okay, so 0, negative 3. What is my slope? 6. Is that a positive slope line or a negative slope line? So is it rising or falling? It's going to rise. It's always nice to think about all this stuff so that you don't make some careless mistake. This is my x-axis. This is my y-axis. All right, we've got some shading. Is this going to be a solid or a dotted line? So we start at negative 1, 2, 3. We're going to go up 1, 2, 3, 4, 5, 6 over 1. 1, 2, 3, 4, 5, 6 over 1. This is solid. So we're just going to do a line. So this is nothing new. Arrows on both ends because they continue on. All right, here's my trick. Yes? No, it's just a solid line. Like I just created these 3 points so I know what to connect.
Are your points always solid?
Yeah. All right, so here's my trick for shading. Put your pencil on the y-intercept. This is going to work for anything that you graph. 2, read your equation and travel up or down the y-axis according to the inequality you read. Okay, so I'm going to put my pencil right here. What does my inequality say? Y is greater than. What does greater than mean? Up. Up means going up. What side of my line am I? We're on the left side. There's my shading. So here's my y-intercept. Greater than means I'm going up the y-axis. Up the y-axis means I'm on the left side of my line. That's the part that I want to shade. If I had less than, I'd be going down the y-axis, and then my shading would be on the right side. Does that make sense? This will be, you'll be graphing parabolas in Algebra 2. You'll be graphing absolute values. This trick works for all of that kind of shading, so that's how I want you to start thinking about it, okay? Pencil on the y-intercept, and then you read this line up here. Y is what? Greater than. Greater than means I'm traveling up the y-axis because I want all the values that are greater than where my pencil is right there. Okay? Let's try the next one. We got to get this in the right format. We have to get this in the right format. So go ahead and solve for y on your own. You should be good at that. You want your y to remain on the left side. And that's what you should get. All right, so we're going to have some shading. Is this going to be solid or dotted? Dotted. There's no equal sign. There's my slope. There's my y-intercept. All right, just graph the line. Don't do the shading part. Just graph the line. Remember to write X and Y axis on your chart. That's what you should have. Put your pencil on your y-intercept and read the inequality to yourself. Y is less than. This is where you read it from, right here, because that's where we have the y by itself. Don't read it from the original. So am I shading above or below? Would you agree we're below? If we're less than, we go down the y-axis, which takes me to the underneath the line. Does that make sense? Okay. All right, do this one. What do we need to be careful about on this one? What negative? Negative 3y. Because what's that going to do? It's going to switch the direction of our inequality. Remember, we keep the y on the left side. So that's your equation that you should be graphing. You've got lots of places to make mistakes. Forgetting to switch the direction, forgetting to change your signs as you're dividing through by negatives. All of which will make your graph turn out backwards. This will be solid because there's an equal sign there. There's my positive slope. There's my y-intercept. Where's my shading? Above or below? What does this say? Y is what? Less than. Less than means below. All right, do the last two yourself. Do both of these last ones yourself. I think probably we're okay on this one. It's the next one that might be a little tricky. Yeah. Yeah, right? That's the place you're going to make a mistake, one of the places, right? Just got to take your time and take a look. This is the one that I want to be aware of. What does a y equal 3 look like? Is it vertical, horizontal, or skew? Where is this y equals 3? Where is y equals 3? Is it on the x-axis or the y-axis? Y-axis. It's got to go through that point. Does that mean I make it vertically through that point or horizontally through that point? Yeah. Solid below x and y axis. Put your point on that value and then draw a line through it. Unless it has an x and a y, it's going to be, only if it has an x and a y will it be skew, which means at an angle. Okay? Are we good? Okay.
Alrighty. What is this class over with? Half hour?